Good afternoon, everyone. I am Chadwick Yasserin, and I am one of the reporters of Group 5 from Bachelor of Secondary Education, major in Science, Section 128. And I'm tasked to report topics about the electroanalytical technique, colorimetry, and also colorimetric method analysis. First, let's talk about the electroanalytical techniques. So may I ask if you know what is electroanalytical techniques? What comes first in your mind when you hear the word electroanalytical techniques? So, electroanalytical techniques, or what we call electroanalytical methods, are divided into categories according to the electric parameters that are measured. Now, the major electroanalytical methods include the following. First is the potentiometry. So what is potentiometry? It measures electric potential by voltage while maintaining a constant, which is normally nearly zero, electric current between the electrodes. Second, amperometry. Amperometry is known to monitor electric current or amperes while keeping the potential constant. Now, let's talk about the conductometry. Conductometry is known as it measures conductance. Conductance is the ability of a solution to carry an electric current, while a constant alternating current with a potential is maintained between the electrodes. And also, let's talk about the electrogravimetry. Electrogravimetry is a gravimetric technique which is similar to the classical gravimetric methods, wherein it describes a bath in which the solid that is weighed is deposited on one of the electrodes. And also, let's talk about the voltammetry. Voltammetry is known as a technique in which the potential is varied in a regular manner while the current is monitored. Now, let's talk about the polarography. Polarography is known as a subtype of voltammetry, which utilizes a liquid metal electrode. And also, let's talk about the colorimetry. So what is colorimetry? It is a method which monitors the quantity of electricity by coulombs, which are consumed during an electrochemical reaction which involves the analyte. And now, let's go deeper about the colorimetry. So, colorimetry, it is known as an electrochemical method in which the total charge or the number of coulombs is being consumed in the redox conversion of analyte at an electrode is measured. So electrode is being measured in the colorimetry. Also, in colorimetry, distinguished from voltammetric and amperometric methods by not relying on mass transport, current control to obtain a signal dependency on concentration. In colorimetry also, it is an absolute method. So, the colorimetry is known as an absolute method in which this colorimetry calibration is generally not necessary, as electrical charge can be measured with high accuracy. Now we are done about talking about the colorimetry. Now let's talk about the colorimetric method of analysis. So are you familiar with this one? So colorimetric methods of analysis are based on an exhaustive electrolysis of the analyte, wherein by exhaustive we mean that analyte is quantitatively oxidized or reduced at the working electrode or reacts quantitatively with the reagent generated at the working electrode. Also, there are two forms of colorimetry. So what are the two forms? So the two forms are the following. First, the controlled potential colorimetry, in which a constant potential is applied to the electrochemical cell. And the other form of colorimetry is what we call the controlled current colorimetry. So what is controlled current colorimetry? So controlled current colorimetry is known for being a constant current, in which a constant current is passed through the electrochemical cell. So the total charge Q in Columbus passed during an electrolysis is related to the absolute amount of analyte by Faraday's law, wherein Q is equal to NFN, where N is the number of electrons that is transferred per mole of analyte, and F is Faraday's constant, which is the 96487 C mole -1, and the capital N is the moles of analyte. On the other hand, a coulomb is also equivalent to an A. Thus, for constant current, I is the charge is given as Q equals to ITE, where TE is the electrolysis time, wherein current varies with time, as it does it controlled potential colorimetry. Then the total charge is given by Q is equal to T equals to TE, and T is equals to 0, where I times T times dt. And moreover, in colorimetry, current and time are being measured, and equation 11.24 or equation 11.25 is used to calculate Q. Equation 11.23 on the other hand is then used to determine the moles of analyte. And to obtain an accurate value for N, therefore, all the current must result in the analyte's oxidation or reduction. In other words, colorimetry requires 100% current efficiency or an accurately measured current efficiency established using a standard. And the factor that must be considered in designing a colorimetric method of analysis.